Hello, this is David from the Package Stage, bringing you a new recording. Today's video is going to be about a package registry walkthrough, and we will see, well, general guidelines, general architecture for the package registry, and also some code. We will dive into some code. So, well, let's get to it. So, the package registry. It's a set of features that will mainly handle communications with the package manager clients. So, for example, npm and GitLab. And so usually the package manager clients will communicate with GitLab through HTTP APIs. So the package registry is pretty much a very large set of API endpoints. And what we usually have on those endpoints, we have kind of three different operations and one thing in common. So the operations first. Since it's about handling files, clients will upload files. So there is an upload, usually there is an upload endpoint somewhere. There is also a download file because clients will want to pull packages, and then basically you have all the other endpoints that the client might need that is not related with file handling. So, for example, some package manager clients will have a search command. That search will trigger a API call, and so there will be a search API endpoint. The other kind of endpoints that we often encounter, it's what we usually call the metadata endpoints. Those endpoints are basically returning the state of the registry. So clients need to have a way to know, hey, what are the list, what is the list of the available packages, or hey, for this package name, which are the versions that you know. And so those metadata endpoints usually will return JSON structures, but it depends on the client, really. It's usually JSON, but it can be also, I don't know, like XML. And those are the kind of operations that we have, API endpoints. And one common thing that we have there is that we have authentication. So the small note in authentication is that we like in the GitLab project, we have a public API, a public REST API that has a very clearly defined authentication. So that there are ways to authenticate against that API. In the package registry, we don't always follow that authentication. Why? Because package manager clients will have their own way to authenticate. So we need to adhere to their needs, right? So as a dummy example, let's say that the client will send a very specific custom HTTP header with the password. So the authentication for the API endpoints there, well, we will need to read that HTTP header and find the user out of that. So yeah, the main thing to keep in mind is that in the package registry endpoints, we actually implement what the package manager clients need. So in the authentication case, if they have a crazy custom authentication logic, we will need to implement that. Otherwise, it will not work. So usually the upload is authenticated, right? You don't want anonymous users publishing packages. That would be strange. The other endpoints like metadata, search are usually also authenticated. The download endpoints, they can be authenticated, but they can be also be public. That what happens you store your packages in a GitLab public project, you usually don't need credentials to pull them. You can pull them in using an anonymous user. So to implement the API, this will be done in the main GitLab project, which is the Rails backend, so Ruby on Rails. And we will also use a small framework for the API. The framework is called Grape or Grape API. Actually, I think it was Grape API. Well, they might have changed. I don't know. So it's basically a small framework within the Rails framework that helps you define API endpoints, implement their logic, like inputs validation and things like that. So they have a pretty extensive documentation on their main website. Feel free to read that, because that's what we use for REST API endpoints in GitLab, and so that's what we use in the package registry too. What we have next? Yeah, so this was the general overview on the package registry. So to start implementing things or bug fixes in the package registry, it's strongly recommended to read the development guidelines. So we have general ones for GitLab, and we have custom ones or specific ones for the package registry. Yeah, I would strongly recommend reading all these because you have several aspects and concepts that we use. I will simply go over a few concepts that are quite important. One is the remote hierarchy or levels, endpoint level. So basically, at GitLab, you will have the set of endpoints for the package manager or the package format, and we will group those endpoints to a specific level. So usually we start with the project level, meaning that the endpoint will target a project, and then you will have all the endpoints, but the entire URL will target a project. We also have the group level. So same thing, but at the group level. So just like the concept above. So we will not target a project, we will target a group. A very specific example. So you store packages physically at the project level. So you publish them on the project level. But you could download, point to the group level to pull packages. So for the download, you point to the group level. And what this does is that the group level will aggregate all the packages of the included projects, which is quite useful, right? If you have multiple packages that are organized in, let's say 10 projects, you don't want to configure 10 endpoints in your projects to pull packages. You could use the parent group that would be just one endpoint, and you could pull all the packages through that. That's the second level, and the third level is the instance level endpoint. It's basically you don't point to any group, any project. It's the entire GitLab instance. So currently we have a few package formats, and all of them implement the project level endpoints. That's the minimum required if you want. And then some of them will implement the group level, some of them will implement the instance level. It depends on the format. One thing for the instance level, because the package is physically stored or linked with a project, when you pull a package from the instance level, we need to give a hint to the backend which group or which project we need to use. And so to do that, we use what we call a naming convention. So it's, it will usually mean that you need the package need to have its name or one of its properties formatted as the group path or the project full path or something like that, because we need to give a hint which group we need to use. We do this to avoid, I guess we could call that package confusion, right? Because if at the instance level you start searching for just a package name and version, well, you could be publishing that package on a public project, but then if I publish the same package name and version, then suddenly all the clients pulling your package will be pulling my package, right? So I'm effectively overriding your package. So to avoid that, we enforce a naming convention at the instance level. So usually it's the root group, so the highest group in the hierarchy, and we need the full path of that root group, so that we know, oh, hey, this is like we need to look for a package, but it will be scoped to this root group, and it's included hierarchy. What we have else, that's the naming convention. Oh yeah, that's one small thing on contributions. When you start doing contributions and creating MRs, we have at GitLab we have a company value called iteration. So it's really, don't try to do everything in one go. This will usually just make things slower. A very specific example is when you open MRs, don't open an MR with like the entire change set, because if it is super large, like 2000 lines of code added, the amount of time that reviews will take will be pretty high, and this is super difficult for reviewers to make sure that everything is fine. Instead, like chop down the work in small pieces, even non-working pieces. That's fine. Like for example, I don't know, we need a new table. Yeah, well, let's open an MR to just add the table, but there isn't, like there will be no logic reading that table, but that's fine. And so because we split things into pieces that are basically non-working, we have a tool for this, which are feature flags. Feature flags are super useful. So you can gate the entire change set behind a feature flag, and it will gate all the access to that change set. And so you can use that to make sure that your ongoing implementation is not is not available right away when it is deployed. There's a feature flag. So strongly advised to use feature flags for those deep changes that will require multiple MRs. If it is a small bug fix where you can like pack everything in a small MR, obviously, well, we don't need a feature flag. Although it depends on how deep the changes are, because if it has an impact on existing behavior, and it is a pretty large impact, well, we might ask you to use a feature flag. Yeah, that's pretty much what I wanted to say. Oh yeah, one small trick. The entire Rails project, we lean heavily on Rubocop. So Rubocop is a kind of, I guess I would say, Ruby source code checker. It will check different aspects of the Ruby code and put errors and warnings about, hey, this line is too long, or hey, don't use this, like use this. So I would strongly suggest to have that configured locally so that it will tell you while you type that you have a problem. If you don't do that, your MR will go through the CI pipeline, and one of the jobs is simply running Robocop and making sure that there is no error. So, well, you don't want to waste a feedback loop of, hey, let's push all the changes to DMR, then you have the CI job running, then Robocop will fail because, I don't know, a line is too long, and then you need to fix that locally. No, it's better to, keep the feedback loop super tight and close, so have Robocop running locally. That's a huge time saver. Lastly, I will point to code review guidelines. This is a general guideline on how to make changes and present them. And there is a section about the merge request author. Have a read, because this is used by all reviewers at GitLab, all reviewers and maintainers. So have a read so that, well, if there is something here that that is stated, don't miss it, so that then you will have the reviewer telling you, hey, no, you need to do this, and it's actually in our code review guidelines. It's kind of wasting a ping pong review for just that. That would be not super efficient, right? Well, that's about the general information on the package registry and the what we do and how to do changes. If we go down a little bit, I'd like to start with the data organization. So the data organization, at its core, we have only two tables. That's the core. One table is the package table. The package table is very simple. It's just a name, a version, and, well, a package type. You have actually the enumeration here. We have, of course, different things on it. We have statuses, we have timestamps and everything, but this is the shared data that all packages across all package types will have. They will have a row in the package table, and it's mainly a name and a version. Then below this table we have package files. It's has many association, obviously, because a package can have multiple files, right? So the package file, it's mainly the reference of the file on object storage. So when you upload a file to GitLab, we will put that in object storage. And to do that, we will have a key for the file. And so the key has to be stored somewhere. And that's the package file table that will take care of this. Well, obviously, again, there are other columns. We don't just have a key and that's it. That would be too simple. We have also other columns, but the main thing is that we really have this association of one package that has many package files. One word on package files. We don't overwrite them. Never. We never overwrite the package files. Instead, we create a new one. And associated to that, the package registry logic will always return the most recent file. So let's say that you publish the same file for the same package name and version, and you publish the file multiple times, like let's say 10 times. We will not have one package file, but we will have 10 package files with all the different contents. But when on the download API endpoint, for example, a client asks for this file, we will look for the most recent one and we will return it. That's a general rule that we have in the package registries, that we always return the most recent object all the time. And that is applied at the package file level. On data organization, Well, obviously, some formats will have additional information about the files, about the packages. So only having two tables is not enough. We will have another table. Not all formats have additional information, but most of them have. So for that, we will have what we call the metadata tables. You can have metadata for the package, so the name and version, or you can have metadata for the file. For example, for the metadata, you could have, I don't know, something about, hey, the runtime version, the minimum runtime version is this thing. Or, well, in this case, I opened the metadata table, well, model, metadatum of, it's the metadata model of the Conan package type. Yeah, I need more tea. So for Conan, packages have a name version, but they also have a username and a channel. And you see username channel. Well, we will not add columns to the package table because that's the general table for all formats. And the username and channel concepts are like specific to Conan. So instead, we have a metadata table that is linked to the package table, and there, since it's for Conan, we are free to add whatever columns we need. And so in this case, we have a column for the username and the channel. We use this at the package level and sometimes also at the package file level. So we can have metadata tables for the package file. Actually, it's the case for Conan. You can see it here. Right, there is a package reference that the Conan client generates, and we need to store that. And so we store that at the package file level. And that's about it for the data organization. So two common tables, package and package files. We don't usually update those because those are the general tables that are used for all formats. And if you need some kind of extension of what we store there, you use dedicated metadata tables. So at the package level or at the package file level, or at both, like in this case for Conan. What we have next? I guess we can open an example. So since we are in the Conan world, in the Conan package tab, let's continue that. So for Conan, recall that I said that we have different levels in the package registry. For Conan, we have the project level and the instance level. The group level is not implemented. So usually what we will have, it's a file. It has the package type, the level, so I guess, and then since it's the package registry, it's packages, and it's in lib API. You see, it's this file. This file is the entire API for the Conan package registry at the project level. It's not very large, right? Yeah. Well, you will see why. Let me show you the Conan instance packages. This one, same thing, super small. And the reason is that we implemented the exact same API endpoint set at both levels, meaning that they have the exact same amount of routes, the exact same routes. So instead of defining them in one file and then in another file, which would be code duplication, and that is a maintenance hell, what we did is that we centralized all the routes in one Ruby module, and we call that the Conan endpoints. Oh, it's actually a concern. It's even a bit more than a module. It's a Rails concern. And here we have all the endpoints. That's where let me see. That's where we have everything. So yeah, the included is not what I wanted to show. Yeah, it starts here. This is the ping endpoint. This is the search, and you have all these endpoints that are defined once, but since the concern is included at the project level and instance level, they they exist in two different routes. So the endpoints, well, as I said, it's what we do is we follow what the client requires. So this is the API for the Conan V1 clients. Yeah, that's correct. It's the V1. So, for example, there is a ping endpoint that a ping route that the client can use to know if the registry is like alive or not. So we need to implement that. We have a search command. Recall that I said that we have endpoints for different operations than just uploading and downloading files. Well, this is the case here. We have a search command, and that will basically call a service. So what is a service? Good question. That's actually an abstraction that we use at GitLab. So I will link the related documentation, but basically we have services that are the logic of the endpoint. Usually it contains the main logic of the endpoint or the main logic of the Rails controller. And this can go like through permissions, authentications, like error handling and orchestrating what kind of data we need to gather and things like that. So yeah, I guess let's have a look at the Conan search service. So yeah, basically here, it's what I recall. We can have a search for an exact match, so a single package, or we can have a wildcard, which is this thing. So in short, the service is already, the logic of this service is like, are we looking for a single package or multiple packages? So if we have a single package, we will use this logic, and multiple packages, different one. And we can see here that for a single package, it will actually call another service, which is fine. You can chain the services. Like this service acts as an orchestrator for the underlying logic. If we have multiple packages, we are going to use a finder. That's fine. That's another abstraction I wanted to discuss. So finders are those that have the logic encapsulated, the logic of accessing data. So in Rails terms, we usually don't access models and model scopes directly. We usually have them in finders. Why? Because finders are usually will usually have additional logic about the parameters. For example, here we have the query. That's an additional parameter that we need to take into account. And well, let's see the Conan package finder. Yes, this one. So you can see that we link different scopes. We have different logic on the scopes, and so we usually encapsulate all these access into a single finder so that clients can just use the finder and that's it, instead of trying to chain the right order of, not the right order, but the right scopes with the right parameters, right? It's all about code organization. So in short, you have the API endpoint, which were here. That's the API endpoint. The logic is usually delegated to a service, and the service can, well, you have more flexibility there. The service can use other services, one or many. It can implement the entire logic by itself. That's also possible. Or it can use finders if it needs to access data. Finders are also used, for example, in the download endpoints. Let me see. I think download endpoints are... no, that's the URLs. So this endpoint is one of those metadata endpoints. It's, hey, give me all the download URLs of the files of this package name and version. That's what actually this endpoint does. And so we will present, hey, I have this file, and if you want this file, here is the download endpoint. So let me see if we can, yeah, here, download recipe files, download package file. Let me see what we have here. Right, it's not here because the Conan logic is in the concern, but it also has been extracted into a additional helper here, API helper. And here, here's the is the function definition. And as you can see, to download a file, we will usually use a file finder. Well, a finder in general. Can be a package file, can be a package finder. It depends. The finder will return the related persisted or database record, and we will use that to send the file back. Well, in this case, we will send a usually we will send a signed URL to the object storage reference. Recall that the package file holds the object storage key for the actual physical file. So we will send a link to object storage for that key. That's what the present package file helper function does. And yeah, that's pretty much it that we have. So yeah, I would suggest, if you want to start contributing to the package registry, don't start with like complex work like implemented a shiny new format. Instead, start with perhaps a small bug fix that will introduce you to the GitLab codebase, and more specifically to the package registry codebase. And then once you have the knowledge, yeah, you can tackle those more complex issues. Yeah, I didn't touch the authentication and everything. I think you can explore it by yourself. It's basically a set of API helper functions that we have, because getting a project out of a project ID, that's something that we will do in several API endpoints, not only for the package registry, for the GitLab REST API, authenticating the user on different ways. For example, here you can see that we allow the personal access token to be sent with basic auth. That's also a helper. So here we are just marking the endpoint that yes, we allow personal access tokens to be sent with basic auth, and that's it. We don't actually implement the hey, let's read the authorization header, then decode base64, decode the value, then extract the username and the password, and find the personal access token with that, and then find the user. We don't do that. We just mark the endpoint, and basically, I think I can show you. We will have, I think it's current user. Yeah, here it is. It's just current user. You call that, and all this logic of getting the personal access token and finding a proper user object will be done for you. Same for project, actually. But you will see that as you explore more of the package registry. Do you have anything else? No. I guess I can give a small summary. So, package registry is mainly a set of API endpoints. To implement those API endpoints, we use Grape API. So, make sure to read the documentation around Grape API. We have some guidelines on general guidelines for GitLab for the code reviews, and we also have package registry guidelines. I will link the documents, but the main takeaway is really work in small iterations and not like implementing the entire elephant feature in one MR. That's really complex to review. And that's the backend maintainer speaking. It's really complex and it takes a lot of time to review that kind of MR, so really keep them small. You can have them as small as having a non-working version, and for that you can use feature flags so that you gate the change behind the feature flag so that it will not be available on .com right away since the feature flag is disabled. Yeah, the next thing, data organization on the package registry. So the package table and the package file tables, those are the general tables. Usually we don't modify them. They are there and we'll just reuse them. If you need to store additional information, we use dedicated tables for each format, so metadata tables at the package or package file level. It depends on the need. And then, the different levels for the endpoints. So depending on the format that you work, for example here, Conan, if you work on Conan on a bug fix, that will fix not only the project level route, but also the instance level route. So just keep in mind that you work on multiple levels depending on the change. You can work on multiple endpoint levels for the package registry. That's about it for me. We linked all the documents in the video description below, I guess. And if you have any more questions, just I guess ping us in the package registry issue, or ping me directly. So that would be at 10io, so 10i, letters I and O, 10io, for me, and we will see how we can unblock you, I would say. Yeah. Okay, so with that, have a great rest of your day, and well, see you around. Bye.